Walaikum assalam. So now we have to start CO4, which you can say course outcome 4, and it is about polymorphism. Previously, we are finished with inheritance. So up to CO3, you will have the exam in the midterm, and then after inheritance, we have this polymorphism and the next topics that will be for the final term, including the midterm topics. So polymorphism. If you just remembered from previous classes that poly means many and morph means shapes. These are the literal meanings of this word. But here in object-oriented programming, polymorphism means performing one action in different ways. Performing one action in different ways. So this has also the same meaning as you have one thing has a different shape. So performing one action in different ways in object-oriented programming is called polymorphism. So for example, here we have a class animal, and this is the starting and ending. And this class has one method, sound. So the definition, yes. So once again, the definition of polymorphism is to perform a single action in different ways. When you are doing one thing in different ways in object-oriented programming, that is called polymorphism. And to understand this concept, suppose we have a class animal, and that class animal has a method, and the name of the method is sound. And then how you can say that what kind of sound this animal is producing? For this example, the class is animal, which is a general class. We don't know either it is a horse or cat or whatever, or cow. We don't know. It's a general class, animal. And this class has a method sound. And then now we want to say something that animal is producing some specific sound. Can you say that a general class animal is producing this kind of sound? Can you say that? For example, the class is animal. We don't know either it is a horse or cat or cow. So we cannot say that what kind of sound this animal is producing. So then what? In this situation, we can use this feature of polymorphism, which is a feature of the real world. For example, horse has a specific sound, which in English it is called neigh, but in our language we can say like that. This is the sound for the horse. And similarly, meow is the sound for the cat. And we have different sound for the cows. And so every animal mostly has the different sound. When you have a general class like that, as you are seeing here, and if you are making a method sound to highlight the sound of this class animal, then you cannot do this thing here. then we cannot do this thing here because this class animal is a general class and we don't know what kind of animal it is. So then what? Then in this situation, this feature polymorphism can help. You can, in this situation, you can create other classes like horse, and in the horse, you can introduce this sound method again, and then you can print system.out.println and horse is making a sound neigh. And then similarly, you can make another subclass cat, and then you can introduce this sound method again in that class, and then you can say system.out.println cat is making a sound meow. And in this situation, you will have three classes. One class is animal, which is the parent class. Then you have the horse class, which is a subclass, child class. Then you have the cat, which is again a child class, and they have the same method in it. The animal class has the sound method. Horse class also has the same sound method, but different message. Cat class also has the same method, but different message. And in this way, you can use this feature of polymorphism in a right way. So in this example, if we have a general class animal that has a method sound, as you are seeing here, as this class is a general class, so we cannot give a implementation like roar, which is a sound for the lion, and meow, which is a sound for the cat, and oink maybe sound for the sea lion or whatever. I don't know. So if we want to use this feature of polymorphism, we can override this method sound. We can override. The term is override. We can override this method sound. Overriding means introducing the sound method in the child class when the same method is also available in the parent class. Overriding is what? This definition will come again, but here overriding means if we have the sound method in the parent class and then you are again introducing the same method in the child class, then the method in the child class would be called overriding method. And this is called overriding method. Now, so from the first slide, you will not understand this concept of polymorphism completely, but when you will go into the second slide, this will complete the concept of polymorphism as we discussed earlier. So now in this slide, we are considering two classes. First class is horse, class horse, which is extending animal, this animal class. This animal class. Now it is parent class. And now this horse extends animal, starting, ending. By the way, these are not the complete examples. These are only giving you the idea. This is not a program which will work, okay? It is only giving you the idea of polymorphism. So now if we have Now we have the two classes, the first two child classes. The first class is horse, which is extending animal class, which is the parent class in the previous slide. And then it's a starting and ending. And here in this child class horse, we have the sound method again, public void sound. This public is not needed, okay? You can remove this public. But anyhow, this is not a complete program. This is just giving an idea. So void sound, starting and ending, and here we have a message which is a specific sound message for this horse class. And system.out.println, we are printing a sound message for the horse, which is neigh. You can repeat the neigh like that. Like that. So we have a different sound in our language, but here in English it is neigh. Maybe their horses have the sound like that, I don't know. But I know that horses have the same sound all over the world. So the class, now we have another child class cat, which is again extending this animal class. This animal class. So that animal is now parent. Extend is inheritance. You know, this is the previous topic, extends, inheritance. So now this cat is a child class. This animal is the parent class, starting and ending. And then we have the same method again, sound, again, starting, ending. And we have a different message for the cat, system.out.println and meow. So this is the sound message for specific for this animal cat. So now if you just look over this previous class, which is a parent class and which is an animal class, and this has the sound message, and then when you will see these two child classes, which is now the part of the same program. So we have this child class horse having the sound method, same method, but with a different implementation message, or with a different message with respect to this child class. And here cat have the same method again, but with a different sound message related to this child class. So now you can build the definition of polymorphism. How? When you have the same method in the child class, which is also available in the parent class, like here in the animal, this is called polymorphism. This is called polymorphism. When you have the same method, two child classes are not needed. Maybe for definition, you can only suppose one child class. So when you have the same method in the child class, which is also available in the parent class with the same name, okay? Same method means same method with the same name. Then this is called polymorphism. I hope you have understood the definition of this polymorphism now. So in this, we have two subclasses. Subclasses mean child classes. It's the same thing. We have two subclasses of animal class. This is the animal class, which is parent. And we have the horse and the cat. And these two child classes are extending this animal class. So now this animal is parent and these are the children. And the implementation of these horse and cat classes is given here, this one and that one, with the sound method, with the same sound method, which is also available in the parent class. So from this example, we have seen that we have common action sound. So in the definition, performing a single action in different ways. So this single action means, the method, because methods are something that you can use in the programs to perform some action. So that's why we are using this word. So we had common action sound. So sound method is common in all the classes. So we have a common sound method for all subclasses or the child classes, including parent class. but all are doing the same action. And all these actions, all these methods are performing the same action. What is that action? Producing sound. But they are producing that sound in different ways. So performing a single action, sound, in different ways, like meow, like neigh. So this is called polymorphism. This is called polymorphism. Now, types of polymorphism. So basically, there are two types of polymorphism. The first one is called static polymorphism, and the second one is called dynamic polymorphism. The other name for the static polymorphism is compile time polymorphism, because it is related with the compiler. When you are going to compile your program, which is the first step before running the program, the first step is compilation. So when you compile your program, at that time, this static polymorphism would be checked. So at compile time, this polymorphism would be checked, and this is called static polymorphism. Dynamic polymorphism is runtime polymorphism. When your program is in its step 2, which is the running of the program, so during the running of that program, this polymorphism will be checked. So that's why we can call it runtime polymorphism or dynamic polymorphism. Now we will see these categories one by one. So first is static polymorphism or the compile time polymorphism. From the previous slide, we know that polymorphism, which is checked at compile time, or you can say which is linked with the compile time, is called static polymorphism. Polymorphism that is resolved, that will be solved, or you can say the better word is resolved. The polymorphism that would be resolved during the compiler time or at compile time of your program is known as static polymorphism. So this is the definition. And what is the example? Method overloading. If you remembered the CO2, in the CO2, we had seen the constructors. And in the constructors, we had seen a topic called constructor overloading. Constructor overloading. And what was that topic? So maybe the name of the constructor is same. You can introduce more than one constructors. One constructor without argument, maybe one constructor with one argument, other constructor maybe with 2 arguments, other constructor with 3 arguments, and so on. So that is called constructor overloading in that CO2. So now we have seen the definition of static polymorphism. And what is the example? Method overloading. And what is method overloading? When you are introducing or when you are writing a same, or you can say when you are writing a method with the same name in a class, when you are writing a method with the same name again and again, but having different number of parameters, which means the name of the method is same. Maybe you have 5 methods having the same name, but their parameters which you are passing into those same methods, if their number of parameters or the number of arguments is different, but different number of parameters, so having more than one method with the same name, more than one method, it can be 4, 3, 2, 5, with the same name, but with different number of arguments and different sequence of arguments, the parameters that you are passing, their sequence, tartib, can be different. I will give you the understanding what sequence means. I will give you the understanding in the next, maybe next slide. Here. So you can write integer first, float after. And if you are writing float first, integer after, then you can say the first is different from the second one. Because in the first example, you are writing int first, float after. This is one tartib, this is one sequence. And in another method, you are writing float first, integer after. You have changed the tartib, you have changed the sequence. So this is called sequence. And different data types of parameters. So this is the definition of method overloading. This is the definition of method overloading. What is that? Having more than one method with the same name, but can have different number of parameters, can have different sequence, and can have different data types of parameters. What are the data types? Integer, float, whatever it is. You will understand. So example of this method overloading is given on the right-hand side. This RHS means right-hand side. This one, right-hand side of the slide, left-hand side of the slide. So for example, here the class is, the name of the class is simple calculator, starting, and here it is ending. And in this class, we have two methods. So now we have the method with the same name, add, and then again add. So having more than one method. So now having more than one method with the same name. So name is same. But their arguments, these are their arguments. Here we have integer A, integer B. So this is 1, this is 2. So two arguments, two parameters are going into it. And here we have 1, 2, and 3. We have 3 parameters. So we have different parameters in both of these methods. So here in this example, we have more than one method, but have different number of parameters, different number of arguments. So this is also the part of the definition. Having more than one method with the same name, but different number of parameters up to this point. This is the example of up to this point. And this method is doing what? This is taking two arguments A and B, both are integer, adding them and returning the value, and the return type of this method is also int, which means this method is returning the result. So A plus B, after addition you will get integer, and that integer is being returned by this method. And similarly here you have 3 parameters, adding them and returning them, and the return type is integer. Then we have another class. The name of that class is demo, and this is not a child class. Okay, this is an independent class. We don't have any extend keyword here. And this is the starting and the ending, and we have the main method. And here we are creating an object for this class. For this class, simple calculator. So simple calculator obj, this is the name of the object, is equal to new simple calculator. This is what, so we have this object obj. Through this object, we can access all this information available in this simple calculator class. So now we are printing a message system.out.println obj, this is the object obj.add, and then parenthesis. From this parenthesis, you should have to understand that you are calling a method here. So obj.add, and then you are passing two parameters into it, two values into it. First is 10, comma, then second is 20. So both are integers. So from these methods, the compiler will go into this class. Obj has the type simple calculator. It will go into the simple calculator. It will find this add method. Okay, this is add. But what the compiler will identify that which method it has to call. It will then count the number of parameters. It is 2. So this add method has 2 parameters. This has 3. So compiler finally will execute or call this add method after counting the number of parameters. So this would be called, this 10 will be copied into this A, this 20 will be copied into this B. After adding 10 plus 20, you have 30. 30 will be returned, and it will return here. And then due to the system.out.println, this 30 will be displayed. And similarly, system.out.println obj.add, we are passing 3 parameters or arguments, which will be copied here into this ABC. After adding, it will be returned, and you will have this output 60. So this add method in this example, this method will be called, or this method will be called. This will be determined by the parameter list. This is the list. This is the list. The parameters which are given to them are called the parameter list.
So why that name is overload?
Because you are introducing, for example, here you are introducing add method, and then you are again writing this add method. So yeah, so you are using this same method again with extra feature, with extra weight. So overload, you can say. Okay. So if you are a single student and you are already doing one assignment, and if I will give you another assignment, then yeah, then I am overloading you, and now you are doing 2 assignments. So anyhow, and this overloading, method overloading, which is the example of static polymorphism or compile time polymorphism. So this overloading will be handled at compile time. And what is the meaning of the compile time? What is the meaning?
Compile time? Only when after the writing.
Another student, compile time. So you know that for the running of your program, you have 2 steps. The first step is compilation. Second step is running. But normally when you are using an editor, you normally click on a play button, and then you don't know when compilation is executed and when your program is running. You don't know because you are using editor. But if you will not use an editor, and if you will execute your program in a command prompt, then first you will compile your program and then you will run your program. And for compilation, you have a command javac. You know that. Okay. So now on this slide, we have the proper definition of method overloading. So method overloading is a feature of the object-oriented programming that allows a class, that permits a class to have multiple methods, more than one methods, with the same name, and now you can give the condition, but with different number of parameters, different number of different sequence, and different data type of parameters. So this is the definition from the previous slide, just repeated. So that's why I have not highlighted it. So multiple methods with the same name, but with different signatures. You can also give this definition. It also has the same meaning. Multiple methods mean more than one method with the same name. Okay, same name with different signatures. And you have the definition of signatures in CO2. This, the name of the method and the arguments, this is called the signature. This portion, this part of the method is called signature, including the name of the method and the parameters and their data types. So for method overloading, you have seen that in this example, we don't have inheritance. So for example, so for method overloading, inheritance is not needed. Inheritance is not the condition for method overloading. Inheritance is not needed for method overloading. But if you will perform overriding, then inheritance is needed. And overriding is the example of dynamic polymorphism, not static polymorphism. So when we will reach at the runtime polymorphism, at the second category of polymorphism, then we will see the overriding. But now we are seeing method overloading. And this method overloading is similar to constructor overloading, I told you. And what is constructor overloading? Having more than one constructor with the different argument list. Same definition. Now, we are going into the details of method overloading. We are in the first category, static polymorphism, which is also called compile time polymorphism. And the example of static polymorphism is method overloading. And how we can do this overloading in our programs, there are three ways. There are three ways to overload a method in your program. What are those ways? Number one, the number of parameters. You can address the number of parameters by giving different number of parameters to your overloaded method. You can do the overloading. Number of parameters, and this is the example. For example, in your program, you have these two methods having the same name, having more than one method with the same name. And in the first method, you have two integers. And in the second method, you have three integers. So here the number of parameters are different in this example. Here in this method, we have two. In this method, we have three parameters. So this is the example of number of parameters. So this is not a complete example, just giving an idea. Giving an idea that if you have two methods in your program and first method is taking two arguments, other is taking three. So this is the example of method overloading, but now this example is with respect to number of parameters. And what is the other way to overload a method? The other way is data type of parameters. You can introduce different data types of the variables that you are passing as a parameter or an argument into a method. And this is the example. For example, if in your program, if you have these two add methods, And the first method is taking integer, comma integer, two integer values. And second method is taking first integer and then float. Then this method has different data types of the parameters, and this method has different data types of the parameters. And through this difference, your compiler can easily identify that which method it has to call. So here, for example, if you will call a method add 10, 5, which method would be called from these two? First one or second one? First one, because 10 and 5 both are integer. And if you will give 5, 2.5, which method will be called? Second, because here you have 5.5, 2.5. So you are giving a float value. So this is an example of data type of parameters. And then the third way to overload a method, sequence of data type of parameters. So this is an example. If you have two methods in your program, add, first is with integer and float is at second position. And in another method, you have float at first position, integer second. So the sequence, now the tartib is different. So this is the third way to overload a method. And now here we have an invalid case of method overloading. Invalid case. Look into it. We have two methods, add, having the same data types, integer, and if you will call add 10, 5, your compiler will call which method? 10, 5. This one or this one, because they have the same parameters. They have the same parameters or arguments. Which method will be called? 10, if you will pass 10, 5, your compiler will be confused.
Second.
Neither first, neither second. You will have a compilation error here. Okay? Because return type is not something which is addressed for method overloading. We are not going to consider return type in method overloading. We only see the method name and the parameter list. Return type is not counted. Okay, return type is not used to differentiate between methods. So that's why if you have the example like that, this is an invalid case of method overloading. Invalid. So it is written here, parameter list does not mean the return type of the method. So parameter list, if you have these parameter list, they have no any relationship with these return types. For example, if you have two methods have the same name like that, with the same parameters like that, same parameters, integer, and have different return type like this, first is integer and second is float, then this is not a valid method overloading example. And this will throw a compilation error. Why? Because return type is not counted for method overloading. Return type is not checked by your compiler for method overloading. And if you have these portions same for the two methods, then you will have the compilation error. Okay. Now, these are just additional information that static polymorphism, we know that it is also called compile time polymorphism. Why? The other name, we can also call it as compile time binding. You can call static polymorphism with another name, compile time binding, or with another name, early binding. I can say early binding. Then you say, what is this? We have not studied this topic. Huh? So these are the different names: early binding, compile time binding, static polymorphism. By the way, here binding means something different, but static polymorphism and compile time polymorphism, okay, that is the same thing. Two names for the same thing. Compile time binding mean it will be checked at compile time. So there is a binding on this method overloading that it will be checked at compile time. Binding means something is connected with something. So this static polymorphism is bound to be checked at compile time. So that's why it is called compile time binding or early binding, because there are two steps, compilation and running. So when something is processing at step number one, we can say this is the earlier step and this is the later step. And this is the later step. So that's why you are saying early binding. So we can also say that it is also called static binding. It's the same thing. Static polymorphism. Method overloading is an example of static binding, which means static polymorphism. And static binding means that these overloaded methods will be checked, or when you call them, when you call these overloaded methods in a main program or wherever, when you will call these methods, this execution of this calling statement will be executed at compile time, will be executed at compile time, which is written here, mentioned here. So method overloading examples. Now we are going to see the first example. And what is the first way to overload a method? There are three ways to overload a method. What are those ways? What is number one? This is the definition. I am asking, there are three ways to overload a method. We can perform method overloading in three ways. What is the first one? This 2 and 3 is not necessary. Maybe your one method has only one parameter and other has 4. So this is again the same thing, okay? But 2, 3 is only the example here in this slide. So answer me in a general sentence. What is the first way? Different number of parameters is the first way. What is the second? Any?
Same parameter.
Same parameter? No. Same parameter, but what is the idea? Different data type is another one, okay. What is the third one? Sequence, which you want to say. You want to say tartib, but you are saying same parameters. You want to sequence, tartib, okay. So now we are going to see the overloading with different number of parameters in signatures. And what is the meaning of the signature? The method name and the parameter list. So different name of different number of parameters. Okay. So now maybe we are expecting that we have some method overloaded and those methods will have parameters but different. So we have a class, the name of the class is display overloading, and this is the starting, and here we are ending this class. And then we have this add method here, and then we have this add method again here. So this is overloading, no doubt overloading. But we have to see different number of parameters. And in this add method, we have two integers a and b. We are adding them, storing the result into another variable sum, which is an integer, and then we are returning this variable sum. And this sum has the data type integer, which has the return type of this method. So that's okay. So this add method has two parameters, two integer parameters. And then we have another add method, which has three integer parameters, a, b, and c. Here we have two parameters. Here we have three parameters. So that's why it is different number of parameters. Here we have two, here we have three. So different number of parameters. And then we are adding, storing the result into the sum, and then returning the sum. So it's the same. Okay, so now this add method, we are writing it more than one time. But here the first appearance has two parameters, the second appearance has three parameters. And then now we are writing another class. The name of the class is Java example, and then we will use these overloaded methods. Starting, ending in the main method. We are first going to create an object for this class, object of this class, because we want to use this information. So that's why display overloading obj, which is the name of the object, and new display overloading, you know that. Through this object, I can call this add method, obj, by using the dot operator. So obj dot add, I can call it obj dot add. And then we are passing 10 and 20, two parameters. This 10 will be passed here in A, 20 will be passed into B, 10, 20, 30 will be stored in sum, that sum will be returned. And it will come here. That 30 will be returned here, which will be displayed by this system.out.println. So that's why you are seeing the output here. And similarly, obj.add 10, 20, 30. So these three integers will be copied here, will be added, and the result will be stored in this sum, which is we are returning it here. So whatever the result is, 10, 20, 30, we have 60. So that 60 will be returned here. That will be printed by this system.out.println command, and you will see the output. So this is an example of method overloading with different number of parameters in the signature. Now, example 2 of overloading, having different data types of parameters. Our data types of parameters are different. So again, we have the class display overloading 2 ending here. We have the method add here and add here. So this is an example of overloading, but we don't know which type. After looking into it, then we can say, here we have integer a and integer b, two parameters. And here we have float a and float b. So data types are different. Here we have two integers and here we have two float variables. So data types are different. Otherwise, this method has two arguments, this method has two arguments. So we cannot say this is an example of overloading with different number of arguments. We cannot say. Different number of arguments? No. Different number of data types? Yes. It is an example of different data types. Here we are using integer data type, and here we are using float data type. So, okay, the rest is same. After adding, storing the result into the sum and then returning the sum, which is an integer, or integer is the data type, return data type. Similarly, A and B adding to float numbers, the result will be float. Okay, so that's why we have the float here. And then returning that sum, and the return type of this add is also float. Okay, we have another class Java example, starting, ending, and in the main method, we are creating the object for this class, which is the display overloading 2. We are creating this obj, which is the object. Through this object, we can access these add methods. And here we are accessing obj.add 5, 15. This 5 will be copied here. 15 will be here. After adding, it will return that sum. So that sum 20 will be returned here. That will be printed by the system.out.println, which you are seeing here as an output. And similarly here, 5.5f, 2.5f. So here it is float. Again, it is 2 arguments. So obj.add, it is 2 arguments. But the compiler will see that here we have 2 arguments, but it is integer, not float. So it will search for another one. Here we have add method, and here it is float. So this f and this f, so now it is matched. And the compiler will call this method and not this method. At this call. And at this call, at previous call, it will call this method with integers and not this method. Anyhow, it will be added and displayed, and you can see the output. So this is an example of overloading with different data types. And now the third one is sequence of data type, tartib. And here we have the class display overloading 3. This is the name, which is ending here. And here we have the add method again. Here we are using integer first and float after. And in the second method, we are using float first and integer after. So we are just altering the sequence of the data types. So now these 2 methods have the same name, but their sequence of variables with their data type is different. And what is written here? System.out.println method with int float, parameter list, param list or parameter list. So the parameters list has integer first and float after. And here we have system.out.println method with float first and integer after param list. And here we are then adding a plus b and returning the result. And here the same. And in the second class, Java example, we have the main method, and we are creating an object for this class because we want to use this information, which is available in this class. So that's why we are creating an object for display overloading 3. Okay, now obj.add, through this obj.add, we are passing 10, 10.5f. This f is for float. It means that this value is float value. So 10, 10.5f. So this, okay, your compiler will go into this display overloading. It will search for the add. We have 2 adds here, but 10 and 10.5. So first is integer, second is float. So it will search this add, first is integer, second is float. And add, first is float, so it will reject the second one and it will accept this first one due to its sequence. First is integer, second is float. It will copy the value 10 here, 10.5 here. It will display this method with int float param list. which you are seeing here, and then it will add those two numbers, and you will have 20.5 displayed by this statement system.out.println. And similarly here obj.add 1.5 f, which is a float, and the second is 1, which is an integer. Float first, integer after. So it will go into this class, and float is first, integer is after. It will call this method. It will display this output first, which you are seeing here, and then after adding, it will return the value, which will come here and display by the system output, and leave this line. Now, the type promotion. In Java, if you will look into this hierarchy, from the bottom to this upward direction, so we have the smallest data type available in Java is called byte. After the byte, the next higher data type is short. And the equivalent data type available for text is character. Short and character have further higher data type integer. Higher means its range will be increased. Its number of bytes will be increased. So for example, if short is taking 4 bytes, integer is taking 8 bytes. And then long, it is further higher than integer. Float is further higher than long. Double is further higher than float. And then finally, we have the object data type available in Java, which can accept all kind of values, string, numbers, whatever. And it is the highest data type available in Java. When a data type, so these are our data types. When a data type of smaller size is promoted to the data type of bigger size, this is called type promotion. For example, if you have given the byte as a data type during a call to a method, but your method is taking short as a data type in its definition, you are giving a value byte to the method, but method actually has the short data type. This will be automatically handled by the Java. This will be automatically handled by the Java. It will accept that byte data type into this short data type, because short is higher, short is bigger than this byte. So it will accept. So this small data type is now accepted by this higher data type. In other words, you can say this small data type is promoted to the bigger data type or higher data types. This is called type promotion. This is called type promotion. Through this arrow, this black arrow, you can have, it is giving an idea that from this bottom to up, you can give data type to any higher. You can give this byte to object. You can give this byte to float. It will be acceptable. Any smaller data type will be accepted by any higher data type in Java automatically. This is called type promotion. For example, byte data type can be promoted to short. A short data type can be promoted to integer. For example, this is short. It can be promoted to integer. Integer can be long. Even integer can be float. Okay, because float is higher. Because float is higher. So a short data type can be promoted to int or long or double. To understand it, now we have a program here. We have a class GFG. Here it is starting and then it is ending here. Okay. Here we have a method, public static void method. These public static not needed. You can start with void just to run this program. Void method. So this is the name of the method, and we are passing one parameter int I. And what it is, system.out.println automatic. So this is the message, automatic type promoted to integer, and then plus we are displaying this value I here. And this is the end of the method. So this I is integer now. Then we have another method, the same method. So this is overloading, you can say. This is called, we can use the same method. So this has the same name. So this is overloading, but not type promotion, but see it first. And here the argument is D, which is double. So double. Now the parameter is double and the variable name is D. And then you are printing automatic type promoted to plus D, and we are just displaying the value of that D. Then we have again overloaded method, same name, but having different data type of parameter. So we have the data type object. This is the data type in Java available. Object, and this is the name. This is the name of the variable O. And then we are printing system.out.println object method called. We are just displaying a text message. And then this is the end of the method. And here we have the main method. Now you will see the difference. Now, what is type promotion? Now you will see. Here we are calling a method. The name is method, and we are passing a character. Because when something is between single quotes are used for character values. So this one, we are passing this data type. We are passing a character into a call of this method. So your compiler will go here. It will look into these methods. There are 3 methods available here. So it will go here, method I, integer I. So this int. So this A. So correct integer data type is higher than this character. Higher? So if it is higher, this character will be accepted into this I. So we are calling with a character. Small a or capital A, the letters A, B, C. And this character is a smaller data type than this integer. So, okay, it will go into this class. First, we have the method, and it is with integer data type. So this A will be copied here into this I. Why? Because this character is the smaller data type, and this integer is a higher data type. So it will be accepted automatically due to type promotion. And now that character value, which was the smaller data type, is now promoted to this integer value, which is a higher data type. So that character A will be copied here, but not into the form of A. What is the ASCII code for the small a? What is the ASCII code? This is a very fundamental question of a. No, what is the ASCII code? ASC, ASCII. What is the number for small a and capital A?
For example,
the number of the
I think 7.
Because computer don't understand ABC. Computers only understand numbers. So what is that ASCII code for A? 97. 97, okay? So that small a is 97 and capital A is what? 65. So it means there is no any good programmer in this class. This is the fundamental question. Anyhow, only one student has given the answer 97, huh? So, so this small letter A, this small character A will be copied here into this I. I is integer, so that A will be converted into its ASCII code, which is a number. What is that number? 97. So when this A will be copied here into this I, this will not become A, it will become 97. And that will be printed at system.out.println, automatic type promoted to integer. And what is the value of I? 97. So that's why you will see automatic type promoted to integer and then 97. This will be, you will see. And this is the minus symbol given here. This is not minus 97. This is already there in the message. And then we have another call method with 2. So 2 is an integer, okay? 2 is an integer. So it will again go here, it will look for the method with integer. So this first one, method with integer, it's okay. So there is no type promotion is needed. It is compatible and it will be displayed. So this 2 will come here into this I and automatic type promoted to integer and 2 will be displayed as you can see here in this output. And then again method with value float 2.0f, which is a float value. So it will go into this class. It will search for the method with float. So method with float, this is method with integer. This is not type promotion, this is type demotion. So it is on the reverse side. So it will not be called. It will go into that method with double. So we are giving a float value and it is a double. So double is higher, float is smaller, but they are compatible. So now the type promotion will work. And this float value will be accepted here by this method and it will be copied into this variable D, which is a double. So double is higher than float and smaller data types are normally promoted to higher data types in Java. So it will be accepted. 2.0 will be copied here and it will be printed then. Automatic type promoted to double and the value of the double D is, you can see the output here. And then finally method with a string message geeks for geeks. Method with a string message geeks for geeks. So it will go and it will search for the method. So this is a string and this is an integer. So it is not compatible. For double, it is not compatible. It is not compatible. And for the last method, it is object. And what is the object data type? It can accept all type of values I told you earlier. Object is a data type available in Java which can accept all type of values, numbers, text, strings, paragraphs, whatever. Whatever you will give into it, it will accept. So geeks for geeks is a string. So it will here, it will be copied here into this O. But here we are just printing a message object method called and it will, as you are displaying here. But if you will write plus O, then you will see this geeks for geeks there. Okay, this is the second category, dynamic polymorphism, but we will start it from inshallah in next class, because from your faces, I can read that you are not in a good state. Revision? No revision. We have sufficient course to cover.
So CO2 and CO3.
CO1, 2, and 3. Okay, CO1, 2, and 3.
I find the record.
Sorry,
Where can I find the record? The lecture.
just a